Hello again. I'm going to go ahead and do a video on long division. This is something that's good to know when you don't have access to a calculator or when your test proctor doesn't allow you to have a calculator. A lot of entrance exams and equivalency exams don't allow you to use a calculator. They want to see what you can do based on grade school, high school level, what you're supposed to obtain from your K through 12 classes, and K through 12 generally doesn't allow you to have a calculator. So when you go to apply to a college or take your GED, they might not let you use some nifty little electronic device. So all of a sudden you have to remember how to do division in your head or on paper. And I'm going to show you how to do that. This is a refresher for that. I've got 4 problems on the paper, and each one is going to explain different issues that could arise from your division problems. The first one is 553 divided by 7, so we're going to go ahead and do that. 7 does not go into 5. It cannot fit. It is too big. It will not go. You cannot cram it in there. So you have to move over to the next number, which is 5. But it's not just 5, it's 55. We've moved over one place to the right. So now we're trying to divide 7 into 55. If you know your multiplication tables off the top of your head, great. If not, do your repetitive addition, whatever it takes to get the answer right. So 7 plus 7 plus 7 plus 7 until you find a number that just barely fits in there. Maybe it might fit in there evenly. In this case, it will not. We're going to use 7 times 7, which is 49. And you write that under here, right underneath your 55, so the places line up. Whatever is on the top and whatever is outside on the left of the bracket multiplied together should equal what you put underneath the number that you are currently dividing. That is the trick. And knowing that and remembering that, top and side multiplies equals, what's underneath here will help you when you get into dividing polynomials by polynomials. Big words, don't have to worry about it right now, but just remember that whatever's on top multiplied whatever's on bottom is going to give you an answer down here. Alright, moving on. 55 divided by 7, the closest you can get is 7 times 7 is 49. 49, so you write 49 underneath the 55, and you create a subtraction problem. 55 minus 49 ends up being 6. Now you've got this 3 and this 6 just kind of like hanging out, dangling around. You've got to do something with that. You cannot divide 7 into 3, and even if you could, you'd still have to manage the 6 down here. Something has to be done with this because it's a remainder left over from the 55. It just can't be there and hang. It's not going to work. So you drop it down, and just a little imaginary line, and this 3 goes bloop right next to the 6. And now you're going to basically be dividing 7 into 63. And 7 divides into 63 evenly this time, 9 times. So you write your 9 up there, and just to show you, you can stop here. Once you get the hang of this, you can stop there and not do anything else. But just to show that there is no remainder and you don't have to go any farther, 9 times 7 for this place. We're doing this place, and we're multiplying this place. Its answer 9 times 7, and we're going to check it down here. So 9 times 7 is 63. 63 minus 63 equals 0. So you know that you're finished, and your answer is right here. It's 79. Nice and simple. Alright, we're going to move on to the next problem now. 421 divided by 5. 5, once again, does not go into 4. It will go into 42 8 times. And that ends up being 40. So 5 times 8 is 40, and we put the 40 right underneath this. Create our subtraction problem, and we're left over with 2. And now we are going to drop down this 1. Uh-oh. 5 goes into 21. It doesn't really go into it. It almost goes into it 4 times. So we're going to put a 4 up here. And 5 times 4 is 20. And now we got this. But we have no more numbers to drop down. We can't divide 5 into 1. We can't do anything else. This right here is the ones place. This is the ones place. And in any number that's not a decimal, there is always a secret imaginative, like an invisible decimal point just to the right of any whole number. We just don't write it because, it's pointless in most day-to-day circumstances. But there's a decimal point there. And on the other side of that decimal point, you have an infinite number of zeros that just keep on going and going and going off to the right. So we need to put that 0 there, because we need a number to work with to take care of this 1 down here. And just like the 1 over here in the 421 that we dropped down, we're going to drop the 0 down next to this 1. And 5 goes into 10 evenly 2 times. So your answer's up here. Your answer is now 84.2. And that's how you deal with a remainder. It's a remainder, sort of. It's a decimal, but you can also convert it into a fractional problem by doing this. 84.2. What place is that 2 sitting in? That 0.2 is in the tenths place. Anything to the right of the decimal does not have a ones place or a once place. It does not exist. It's a tenths place. So that 10 in the tenths place is important. We're going to pop that 84 off that 0.2 and bring the 0.2 over here by itself, and we're going to put it over its tenths place. That there is tenths. And once you reduce it, you'll end up with 1/5, because 2 goes into itself 1 time, and 2 goes into 10 5 times. That's fractions. Dealing with that in another video, but just trust me. So your fractional answer to this division problem up top is 84 1/5. So 84 1/5 is the same as 84.2. Just knowledge for the future. Alright, moving on to the next problem, we have 389 divided by 4. 4 does not go into 3, so we move on to the tens place, which is going to be 38. And 4 will divide into 38, but not evenly, of course, because that would be too easy, right? Or it divides in there 9 times, because 4 times 9 is 36. So drop it down. Do your subtraction problem. Remember, all these are subtraction problems. So you got 2. You're going to drop your 9 down. And 4 into 29. Do your times tables in your head. You figure out that 4 times 7 equals 28. 28. And you're going to drop down your 1. And just like over here on this problem, we have nothing over here. So we're going to take our invisible decimal point, and we're going to put a 0 there, and we're going to put a 0 here. 4 goes into 10 2 times, almost, but we have, because, 2 times 4 equals 8, we're going to drop the 2 down. Uh-oh, we still can't do anything, because 4 won't go into 2, so you just keep adding zeros, and then you drop that 0 down there. Ah, finally, 4 will go into 20 completely evenly, and it will go in there 5 times. So now you've got your answer up here. There's nothing left to do, because 4 times 5 equals 20. And 20 from 20 is 0, or 20 to, from whatever, subtracted, is 0. So you're done. Decimal conversion for this one, since we've taken it to the hundredths place on the right side of the decimal, would look like this. It's a little bit different than over here where we had the 2 tenths. We're going to take the 97 and put it aside while we work with the 0.25. Now the 0.25 is sitting in the hundredths place. The 2 is in the tenths, but the 5 makes this number, this 0.25, exist in the hundredths world. So instead of putting a 10 under it, we're going to put 100 over it. And if you know anything about money and quarters and pennies, you know that this is going to eventually reduce down to 1/4. Your final fractional answer for this problem is 97 1/4. Ooh, alright, our last problem. 3 into 22. 22 divided by 3. Alright, 3 will not go into 2. 3 will go into 22 7 times. And you'll get 21 left over, 1. Going to do our nifty invisible decimal point. the 0, drop it down. 3 goes into 10 3 times, because 3 times 3 equals 9. 1, uh-oh, what is this? Drop the 0 down. So 3 goes into 10 3 times with a 9, drop. It's going to keep doing this forever and ever and ever and ever and ever. It is a a repeating number, a repeating decimal number. It will not stop. It'll keep going. And in order to write that in a simplified form, instead of just writing, filling your page up with 0.333333, what you do is you will take this number and you will write it like this, 7.3, and then put a line over the portion that repeats. So like, let's say you had 7.654, and that 654 just kept going on and on and on forever and ever and ever, and you're never going to get out of that loop. You would write it as 7.654, and you would put a line over the 654 to show that that's the part that repeats. That's about it for long division. If you have any questions, please leave them in the comments of this video. If I said something goofy or did something incorrect, again, please let me know in the comments. I'm not very skilled at the video making thing. I'm getting better as I go along, but thank you for watching. I hope I helped somebody, and have a good day.